So, last time we did talk about bendo-mexo. That endothermic is about breaking bonds. Exothermic is when the bonds are made. So energy is taken in to break the bonds. We have to put that energy in, and we make energy when the bonds come back together in a new arrangement. Every reaction is about breaking and making bonds. Now we're going to talk about something called bond enthalpy. Now this is one of the more difficult topics that people find very difficult, but it's actually quite simple maths, and it doesn't really, and for those who understand it, it is far more easy than a lot of other topics. Now, all that you've got is the fact that there is a lot to do, and there's a lot of numbers which are on the page. So we have to make sure when we're actually writing the answers to this, we lay it out well. Every single bond has a bond enthalpy. Now that bond enthalpy is literally the energy that is either required to break a bond or the energy that is made when that bond is created. Now for instance, C to H has 435 kilojoules for every mole. O to O is 498 kilojoules for every mole. C to O double bond is 805 kilojoules for every mole. And lastly, water, 464 kilojoules per mole. Now that means that if I put 435 kilojoules into a mole of the C to H bonds, I will make them separate into C and H alone. If I put 498 kilojoules per mole into an O double bond O, it would separate into two O's. Also, if I had two O's and then they came together, I would make 498 kilojoules per mole that comes together. That's the energy required to break or the energy that is made when they are made. That makes it very easy to actually work out our reaction. So here I am breaking 4 times C to H bonds. 1, 2, 3, 4. I'm also breaking 2 O double bond O's. On this side, I am making 1, 2, 3, 4 O to H bonds. I'm also making 2 C double bond O bonds. If I look at that then, I literally can just put the numbers in. You'll find these on any exam question. So 4 times C to H, 4 times 435 plus 2 times 498. Because I'm putting in energy and endothermic is positive, these two get plus. These two, I'm making a bond, so energy is released. It's endothermic. So I have 4 O to H bonds. So I have minus 4 times 464. I'm also making 2 C to double bond O bonds. So I minus 2 times 805. Now this is going to give me a value, if I put this into my calculator, of minus 730 kilojoules per mole. That means, because it's a minus, it is an exothermic reaction. If it was a positive, it would be endothermic. Now something that is really interesting is you get marks for nearly everything in this. It is always worth saying bonds broken. above the calculations where the bonds are broken. It is always worth saying bonds made above the calculations where the bonds are made. In fact, it's sometimes also worth writing down what the actual values of each of these are and then doing bonds broken minus bonds made, because everything in this gives you extra marks. Now there are lots of other examples attached, but just make sure that this is entirely about practice. You go through the steps, you find the bonds broken, you find the bonds made, and you just tally them up and add up the values which you are given. Now, I hope that's useful. Please put in any comments if there are any other things that I should be. Thanks.